Okay, good morning, everyone. How did the homework go? Do you guys have any questions? Please put your questions on chat if you have any. Okay, so while you're looking at whatever notes you have, I would like to announce that exam 2, so your second exam is next Wednesday. So next Wednesday, it would be March 31st. Okay, so exam 2 is Wednesday, March 31st. Yeah, thanks. Keep putting problems on chat, but I want to make sure I announce this. The review will be out tomorrow at the latest, and I strongly advise you to come on Monday having done the review and the homework. Remember that if you guys do well on this exam, I will take care of exam number 1. As I told you, the exam number 1 will be replaced by the average between exam 1 and exam 2. So if you guys do well on exam 2, you can definitely compensate for exam 1. So it's your chance. There is not a lot of material on this exam, so you should be able to do all the review and ask me lots of questions on Monday. Okay, so the minute the review is out, I will email the whole class that the review is out, just start. Okay, now I go back to your questions, section 9.1, sorry, 9.1, okay, and one problem I don't understand. Can you go over number 17? Rebecca was from which section? Rebecca? 8.3, okay. So we're gonna do first number 17, section 8.3, and then we're going to proceed to the other two problems. So 8.3, let me get that clear. And number 17, 8.3, number 17. All right. Convert the Cartesian coordinate to polar coordinate. So we have to convert from Cartesian to polar. And the point is minus square root of 3 and 1. Okay, so this is the Cartesian, it means, and then we have to find the polar. So step number 1, before I use any formula or whatsoever, so let us make, they don't say in degree or in radian, so let us do it in degree. And in your exam, I will do my best to remember which unit you should be in. So step number 1, I draw the point. I don't use formulas at all. I first draw the point. So the point is minus square root of 3 and 1. It should be here. That's 1. So that's really my point right here. Okay, that's the point. And I need to find the r and the theta. So now I need to find this angle. Okay, and I need to find r, which is go from here to here. Okay, so these are the polar coordinates. Okay, first for r. What is r? R is from Pythagorean theorem, is the square root of the x squared plus the y squared. Okay, so that's the r. It means the square root of x is minus the square root of 3 squared plus y squared. It means the square root of, now this is minus square root of 3 squared, that's a 3, plus 1, square root of 4, which is equal to 2. Okay, so this takes care of the first piece. So this takes care of r. Now theta, and believe me, theta, you can, I will use tangent, but you can find theta almost any way you want. I mean, you can use, if you want, okay, let's do it the way I've been doing it. I go over the tangent of theta. Okay, so tangent of theta is the y over the x because it's the sine over the cosine. So my y here is a 1 over minus the square root of 3. Okay, and theta, and that's important. So that's the tangent, and theta is in the second quadrant. Be very careful with the location of theta because that's so. The tangent is -1 over, and theta is in quadrant 2. So what is going to be theta? Now, if I take arctangent -1 over square root of 3, and I plug that into a calculator, so that's not the answer yet, and I plug that into the calculator, so if I go, this is my calculator, and I wish it was lighter, and I told you the mode is degree, so I'm going to check my mode here. It's in radian, because very soon I'm going to switch to radian, so that's the mode. And I'm going to take tangent inverse of -1 over the square root of 3. So that's exactly what I'm doing. And I'm getting a syntax error, so I repeat. So tangent inverse of -1 over the square root of 3. Okay, I shouldn't have syntax. I'm getting -30 degrees. Sorry. Okay, because now, is theta -30? Is theta, can theta be -30? Yes or no? Look at your picture. -30 is basically the angle right there. That's what the calculator gives you. The calculator will give you the angle between -90 and 90, whose tangent is -1 over square root of 3. But there are not only one angle that satisfies this condition. There are a lot of angles with the same tangent. So to get the angle I want, I have to add the 180. Okay, so the calculator will give me that, but that's not what I want. I want theta. So to get theta, it's basically the 80, you're taking away the 30. So it's going to be, which is 150 degrees. So my polar, my angles is 2, so in polar coordinate, 150 degree. I stop. Questions about this problem? So whenever you go away from Cartesian to polar, step number 1, you draw the point. You have to know where your angle is. Drawing it tells you that you are in quadrant 2. When you use the arctangent, because it has to give you one angle whose tangent is -1 over square root of 3, and there are a lot of them with the same tangent. It gives you one, the one -pi over 2 and pi over 2, or the one between -90 degrees and 90 degrees. That's the one the calculator gives you. That's the calculator. To get the one you want, you have to add the 180, and that's where you get exactly the one you want. All right, questions about that? Rebecca, is it making any sense? Yeah, okay, very good. Now I move to the other questions. 27, 26. So 27, section 9.1. Okay, so we're going to do number 26 first, of course, and then 27. We'll go in order. Number 26. And the question is, solve sine x equals 0.3 for x between 0 and 2 pi. Okay. All right, so that's the question. And then we're going to graph sine x and show the solution on the graph. All right, so the first part, I want you to solve them using the unit circle and the symmetry on the unit circle. So what I mean by that, which is I've done several times, I'm looking for an angle whose sine is 0.3. So I go my circle, That's my famous unit circle. Okay. The angle is the sine, 0.3, sorry, 0.3 is right there, because that's the unit circle, so 0.3 is right there. I'm looking for an angle between 0 and 2 pi. So the unit circle tells me you have two of them, this one and that one. Both have sine 0.3. Okay. Now I need to find them. I'm going to call them, as I said last time, I'm going to call them, let us say T1, so to differentiate them. And I'm going to call this one T2, just to differentiate that I have those two. Both angles have sine 0.3. Now we have to find them. So what's going to be, sorry. Would it bother you if I put T instead of X? Does it matter? Yes or no? Does it matter? No, 4. Okay, so what when I get T? So first value of T is the arc sine of 0.3. And this would give me the angle in the first quadrant. So if sine T equal 0.3, the angle could be in quadrant 1 or in quadrant 2. The sign is positive, so either here or here. And the question is, we need to find both of them. The arc sine will give me 1. The symmetry of the unit circle will give me the second one. So this is going to be equal to. Okay, please guys help me out. Now, because it's between 0 and 2 pi, I have to put my calculator in region mode because that's what they're asking. Okay, so I need the sine inverse of, how much did you guys get? You have to start working with me. 0.3, which is 0.304, and that's region. Right? It means on the unit circle here, this is 0.304. That's what it is. So the arc sine will give me the one of them. The unit circle will tell me, you know, but you have two angles that have the same sign. So what's going to be T2? So that's why I'm introducing T1 and T2. So we differentiate them. Who can give me T2 using the symmetry of the unit circle? Use your picture. And 2.37, anybody else agree with him? Okay, so everybody is right. It's a pi. Basically, you're taking the pi and you're taking away this angle. So minus 0.034, which is, I will copy verbatim what you guys gave me, 2.837 region. Okay, so these are the two angles that between 0 and 2 pi that satisfy this question. So 2.837 region. Okay, now let us say I ask you the following question. Solve. Okay, but I want the solution, all the solution between 0 and 4 pi. You know, 0 and 4 pi, it means 0 to pi, we'll go wrap around the circle once. 4 pi, I'm going to wrap around the circle a second time. So now the question is, it's the same thing, but I want all the solution between 0 and 4 pi. How many do you think we're going to have between 0 and 4 pi? How many solutions? How many values of t? When I plug it here, I'm going to get 0.3 between 0 and 4 pi. Between 0 and 2 pi, I have two of them, this one and that one. So if I go around the circle one more time, how many of them do you think we're going to have? Anybody else? Absolutely, we're going to have 4 solutions. So what are they? What are the 4 solutions? So we have the two basic ones. This is one solution, and this other one. If I want more, I say, okay, T1 is a solution. Another one could be obtained by starting from this and going around it, a full circle, so wrap around the circle. The value of the sign will not change. So the third value is going to be this, the first one, add 2 pi to it. I will have a new solution. It means if I plug in this angle for t, I'm going to get honest to goodness 0.3. And now I just add those. So add those plus 2 pi. I'm going to 6.58, 6.588 almost. That's another solution. It's obtained by wrapping, starting at T1, going around a full circle. The point is not changing. The sign is always 0.3. I can do that for T2. I meant for, yeah. So I take this one and I add to it another 2 pi. So now I'm working with the other angle. I take T2 and I go around the circle 2 pi. I'm not gonna change the value of the sign. And we can compute this value, all right? The last piece in this problem, I'm just using this problem to elaborate, a lot of ideas. The last piece is the following. Okay. So we solve sine t between 0 to pi. We solve it between 0 and 4 pi. The last thing, the idea is the following. Suppose I give you the graph of sine. That's the graph of sine of t. And I'm going to draw it over a 2 period. So remember, the graph of sine starts here. And it goes up, down, up. That's a full period. Then it goes up, down, up. And that's a second period. So that's the graph of y equals sine t. All right. And now on the graph, you want to see what we did. I mean, we want to visualize everything we did on the graph of sine. So this is the graph. Suppose the question is find all t such that sine t equal 0.3, which is the problem I find. It means all the points such that sine t equal 0.3. So let us see graphically what do we mean by that. It means that this is the output value of sine. So if this is 0.3, what I'm really after is all the angle whose sine is 0.3. So the graph immediately shows me that you're going to have 4 of them. This one, right here, the sine is 0.3. This one right there, this is my T1, the one I got. This is my T2. And then it is periodic. It means from here to here, I'm adding 2 pi. This is my T3 right here. So we have 3 values. And then I'm going to add another 2 pi, and this is my T4. So on the graph of sine, these are the solution of sine t equal 0.3. Okay. Questions before I proceed? All right. Okay. Now we'll do the last one. And this one I will give you in 2 minutes. I'll see what you guys come up with answers. So this is 27 before I move on myself. So let's see what you guys have asked. Okay, 27. Is cosine. Let me write cosine t because it's, I think they should have used cosine t. Minus 0.7. And I want you to give me all the solution between 0 and 2 pi. I give you 2 minutes for the answer, and I want them on right space. Sorry, I want them on chat quickly. I'm going to ask one of you to find me. Step number 1, you have to draw the unit circle. And I'm going to be very picky about it on your exam. I want the unit circle, and I want you to show me everything on the unit circle. Remember, the cosine is the x coordinate. Okay, I'm getting the first answer. She was faster than I was. Yep. Anybody else? Anybody got anything close to what? Okay, I'm having. All right, Jaden, I'm gonna zoom on you and tell me what you did.
To find the first 2.346, I took the inverse of negative 0.7 cosine.
Yeah, first
inverse.
on the unit circle, because I know you guys hate that. On the unit circle. Where is
on the left?
On the left?
Cosine the x-coordinate, so on the left side it would be a negative, so I put the negative 0.7.
Okay, what are your angles now? How do you draw your angles?
My top, I went straight up and then straight down.
Right. So this is your angle. That's the one. So that's one of them. We're going to call this my T1. And this is the other one. So I'm giving them name to totally distinguish them. Okay, very good. Now, what's your first angle? Jaden, you proceed.
For T1, I got 2.346. And to get that, I took the cosine inverse of negative 0.7.
Very good. And how much you got? I will copy yours.
2.346.
Very good. So that's how you get the T1 from basically, that's the arc cosine. The T2, this is the one you have to use the unit circle. So what is the T2?
For the T2, I got 3.937. And the way I got that was I took 2 pi minus 2.346.
Exactly. So he took 2 pi, but he took away that piece. Basically, that's what he's doing. So he took away. So this from here to here, that's 2.346 by total symmetry. I mean, that's the heart of it. We're using symmetry. We have no choice. So the second value is going to be the 2 pi minus 2.346. And he's absolutely correct, which is 3.937. Okay, this will give me all the values. Now I can start pushing you between 0 and 4 pi. Between 0 and 4 pi, you know what to do. So the solution between 0 and 4 pi, so you have between 0 and pi, between 0 and 4 pi now, you have one solution, you use T1, you wrap around the circle once, you get another solution, you have T2, wrap around the circle once, you will have a third solution. So all the solution would be T1, T2. So T1 are the basic ones, and then you start adding or subtracting 2 pi's, nothing will matter at this stage. So this is T3, and this is T4. So T3 is going to be 2.346 plus 2 pi. You add 2 pi to this, and T4 you can start adding 2 pi to that. If you want all the solution between 0 and 6 pi, you keep adding 2 pi's, 2 pi's, 2 pi's. All right? So finally, on the graph of cosine, let us see the solution. So on the graph of cosine, means if I sketch the graph of cosine, sketch the graph. So this is cosine t. Thank you guys for the answers. And I sketch the graph. That's how it works. Over one period, and the graph starts repeating itself. That's a second period. And I'm asking myself, all the cosine, which is minus 0.7. So minus 0.7 is, so the cosine takes this value, and I'm asking which input will give me a cosine minus 0.7. The graph tells me 1, 2, 3, 4. So these are the values we found. The first one, this is the one that the T1, the arc cosine. This was the T2. And this was my T3. And this was my T4. Okay. These are the, graphically, that's really what's happening in the picture. Questions before I proceed? Okay. Today we're going to keep working along the same lines, and hopefully we will do like a story problem. But before that, there are sometimes, I mean, these are important to be able to do any story problem. We're gonna solve the following type of equation. So suppose, and I'm gonna look only for one in those. I will not look for more. We will do that in the story problem. So suppose I tell you, find one solution, not more. Find a solution to the following equations. Not one, only one. I don't want more than that. A, sine, watch careful what I'm gonna write, 2t means sine 2t equal to 0.4. Okay, so I want to find a solution for that. Now, be careful here. Inside the sine, I don't have t, I have 2t. The process is the same. So if sine 2t is 0.4, what does this mean? How can I find t? Can anybody give me an idea? So find a solution, it means find the value of t. When I plug it here, the sine of 2t will give me 0.4. How can I solve something like that?
You have to isolate the t first.
How can I isolate the t?
You can first move over the sine and then divide it by 2.
How can I move over the sine?
By getting the arc cosine of 0.4.
Arc sine. Absolutely correct. So basically, she wants to isolate the t. So to be able to do that in this problem, you know, I have basically inside here 2t. So the way we're going to do it is what she's saying. She want to isolate it, but how to isolate it? I have a sine. The only way I can isolate when I have a sine is take the arc sine. So this is going to give me very carefully 2t equal 2t equal sine inverse or arc sine of 0.4. So now I'm going to get 2t. It means 2t equal, and then arc sine 0.4. So let's, since I am in radian, I'm going to state in radian. So arc sine 0.4, which is going to give me 0.411. It means t equal 0.411 divided by 2. It means my t is equal to this divided by 2. I can do that in my head. I'm divided by 2. 0.2055. Okay, so if I have 2t equal 0.4, which is a lot of time, you guys will have to encounter those because those represent periodic function of period pi in this case, you're gonna take the 2t equal to that. Now, if you wanna check your answer, because sometimes checking will help you out, you just plug in t in here. So you plug in t there and just you check, do you get exactly 0.4? So if I check, so this is gonna give me sine of 0.411. As you realize, I'm going backward. The sine of 0.411, if I plug it into the calculator, I'm gonna get 0.4 exactly. So we're gonna do 2 problems along those lines. Problem number B, I want you to solve the following, and I want only one solution. 5 cosine pi t, and why not, plus 4 equal to 3. Okay, suppose I want to solve this type of trigonometric equation. All right, how can I do something like that? Start giving me ideas.
Would you subtract the 4 first?
I'll subtract the 4 first. Very good. So it's going to give me subtract 4. And then what would you do? And what's the idea? What's really our idea at the end? Proceed. The one who's talking, proceed.
To get t by itself.
Yeah, so what do we want to do now, you think?
Divide by 5.
Right, we're going to divide by 5 because we really want to isolate the cosine. So divide by 5. Now we're isolating the cosine. So we can basically isolate the pi t. First, I isolate the cosine. And now what do we say? How can I get the t?
Divide by the inverse of cosine.
Yeah, not divide. Take the inverse. Means pi t this time. And that's what you have to be careful with. Pi t is the cosine inverse of -1/5. Okay, so what you have to be very careful is that the pi t is the cosine inverse. That's really the difference. There is not only t, this whole expression should be the cosine inverse. Now, the rest will not be hard because I can compute the cosine inverse of -1/5. And it's giving me 1.772. This is pi t, and then my t, I divide by pi now. Will give me 1.772 divided by pi. So I divide this by pi, and I'm getting 0.564 and of the problem. Okay, so solving this, basically step number 1, you have to isolate your cosine, but then you have to be careful that the pi t is the cosine inverse, and then you solve for the t. Okay. One more problem, then you guys will do it, and then I'm going to take some kind of a story problem. Find, again, solve the following. 2 tangent, because we haven't worked with tangent enough, 3 theta plus 6, for example, equal 220. Okay, and my question is, so for theta, you guys have 2 minutes to do that. Okay. All right, so please do the following again. Those are not hard, but the idea is that I have 3 theta in here, and I have to pay attention to that. So whenever guys you get your answer, please put it. So I'm having some answers. Okay, it seems there is a consensus. All right. Okay. Anybody else? So let me pick one student, see what they are doing. I don't know. Lucas, are you with us?
Yeah, I am, but
Okay.
not doing too well in this section, so I'm not sure.
All right, so let's work together. Let's work together on that. How shall we solve here? The idea is we have to isolate this piece first. Okay? How would you isolate this part? What
So
would you do?
divide the left side by 2?
No, not first. What do you think the better thing to do first?
Maybe get the 6 to the right side?
Exactly. That's the better way to do it. So we're going to take away the 6. 20 minus 6, give me 14. And now we want to isolate this term first. Equal to 7. Are you with me so far?
Yeah.
Okay. Now I want the 3 theta. I want to basically, find the 3 theta. Now what does we have? If we know the tangent and we want the angle inside, that's when we use the arctangent. It means the 3 theta, the angle inside, is the inverse of 7, is arctangent of 7. Now the rest is basically, I can pick up my calculator, compute tangent inverse of 7, and I'm getting 1.429 almost. And then to get theta, isolate theta, I divide by 3 across. And then I divide by 3, which is going to give me what your students are getting, 0.476. Okay. So a lot of time we're going to encounter those problems. We will encounter them in a minute. And then the way we solve them is actually the same. The only thing we have to be careful with, if I have 3 theta in here, then it's the 3 theta, which is the arctangent. It's not really the theta. All right. Now we're going to take a story problem that we've done at the beginning of the semester, but now we're going to do that we introduced at the beginning of the semester, but now we're going to be able to do more with them. But before I get to this problem, let me remind you the following, because I think you might have forgotten that. Let us recall. What we call the sinusoidal function. Sinusoidal function, those are functions of the following form. It's A cosine bt plus k, or y equal, so those are functions that look like cosine or they look like the sine, but the period changes and the midline changes. Now, those functions, let us remember that. So it looks like cosine, but the A, its effect is to stretch the cosine. So stretching the cosine will make the amplitude to be A. It means the distance between the midpoint and the max. Now the B will affect the period. Let us remember what was the formula for the period. So if you have B times T, anybody remember the formula? Anyone? Okay. Will be 2 pi over B. So this will be a periodic 2 pi over B. And then the midline, okay, the midline, it means the shift, how much we're shifting up the sine and cosine. The K will give me the midline. Okay, so functions of this form that we've seen at the beginning of the semester, and you guys knew them, but they look like cosine or like the sine. And let us remember the graph of cosine start at the max, go down, up. That's the cosine. And the sine start at the midpoint, go up, down, back here. So this is the sine and this is the cosine. Okay. Those functions will basically stretch the cosine, either shrink it or expand it by affecting the period, and shift it up and down. So this is a quick reminder of those functions. And we use them to represent population, which is going up and down, and the Ferris wheel problem from the beginning of the semester. Okay. So now we're going to do the following problem together. I'm going to read it. It is on Brightspace, the worksheet, but in case you guys want to write it, I will read it very, very slowly. Okay, so let's see what this problem is about. You have an animal population that actually go up and down, increases from a low of 1200 in the year t equal to 0. So it's a low here of 1200 to a high of 3000 4 years later. So it goes up to 3000. And then it's going to decrease back to 1200 over the next 4 years. So it starts at 0 at 1200. It goes up here, and then 4 more years, it's down here. And basically, it repeats the cycle after that. So it repeats the same cycle every 8 years. So it start, go up, down, stop, start, go up, down, and stop. Okay, so it's a typical sinusoidal function. It means the graph has a certain symmetry to it. Okay. All right. Question number 1 is find the period, the amplitude, and the midline. So what is the period? We're going to do it 2 ways, by looking at the graph and figuring it out from the formula, because I gave you the formula here. So what's the period in here? Okay, back to you. What's the period? It means how long it takes for it to repeat the cycle. Anybody? Okay, the period is equal to 8 according to the picture. Or if I did not have lines here, you can say in my scenario, the b is pi over 4. So if I did not put values, because, or which is 2 pi over b, it means 2 pi over 4. Now, dividing by fraction means you multiply by 4 over pi, which is equal to 8. So the period is equal to 8. Right. Now, what is the amplitude in this problem? What's the amplitude? It means what's the, according to the formula, from the formula, it means what is the distance between the highest point and the midpoint of the graph. So what's the amplitude here? No, 900. That's my amplitude. My amplitude is always the A, which is 900. And what is the midline? The midline, okay. The period is 8, amplitude is 900, and the midline is 2000. Okay, so I'm going to draw the midline because usually the midline helped me tremendously to understand the graph. So that's the midline because it helped me to orient. So that's the midline, it's at 2000. So this is my midline right there. Okay, that's the midline. Very important to remember the midline. So I'm going to even put it in red. So we draw it. Okay, this is the midline right there. All right, that's a 2000. And let me ask you, see, what's this point here? This is the midline. The period is 8. The graph has a total symmetry. It means this point here should be at 4. This point here should be 2. And this point right here should be 6. So that's really my picture. Question number 1 is the following. Find the population at t equal to 3. Okay, find the population at t equal to 3. So so it means if t is equal to 3, what's the population? You have a formula for it. Give me the population at t equal to 3. What am I asking here? The population at t equal to 3. . . 3 . . 3 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, how can we get that? Remember, I have the formula for the population. I want the population at t equal to 3. How would we do that? Are you guys doing it? Plug it in for t. Exactly, so let's plug it in for t. So I need to find the population at 3. So I'm going to plug 3 in the formula. I will get minus 900 cosine pi over 4 times 3 plus 2000. So it means I will get minus 900, the cosine of basically 3 pi over 4 plus by itself 2000. And the rest I will plug it inside my calculator. So I'm going to have minus, I'm going to take 900, and my calculators, all of us should be in radian. So thanks for the answers. It's 900 times the cosine of 3 pi over 4. So I'm getting minus 3.396 plus 2000. And this is going to give me 2,636.396. Okay, so that's the population after 3 years. Okay, so if I know the formula, it's easy to find the population. Now, question number 2 is the following. Find the first time when the animal population is 1,400. So now what I'm asking you is, find at what time, it means after t equal to 0, it means after how long, after how many years, if you want, is the population equal to 1,400. So what am I asking you to do now? So on the graph first, this is 1,000, this is 2,000. On the graph, this is 1,500. So now what I'm asking you, I'm giving you the population, 1,400. And what I'm asking you is basically to do that. I want the time when the population is 1,400. I want the exact time. So I want the time when the population is 1,400. Now I'm going to drop this one. I don't want to be, so actually, yeah. So I want those 2 points when this is happening. I want the time when the population, I want the first time. It means I want this interrogation mark, and then we're going to find this after that. Chris, what do you want me to do to solve this problem? Find the time when the population is 1,400. What do you want me to do? I keep it. I want you to interact with it, and you tell me what to do. Set the population equal, plug into the equation of the solution. You may be right if I understand what you mean. So I want to find the time when the population is 1,400. So what do I need to do? So this is my population right here. I want to find when, for which time t, the population is 1,400. What do I want to do? Please speak up if you. Okay. Tim De Silva, are you with me? Tim? Okay, I don't think he's with us. Travis, are you with us?
Yeah, I'm here.
Okay, how do you think we're gonna do this problem?
You would do 1,400 equals negative 900 cosine pi over 4t
Right.
plus
We're gonna set-
2,000.
Yeah, we're gonna set this equal to 1,400 and solve for t. Okay, so to know when this happened, we had to solve this equal to t. Okay, let us do that. And this is what we did a minute ago. That's why we started with those type of problems. But now they make sense. They make sense. That's why we use them. So now we're going to solve for t. So to solve for t, I need to isolate this piece right there. To isolate it, I have to take away 2,000 from both sides. So I'm going to subtract 2,000. And this would give me minus 900 cosine pi over 4t equal 14,000 minus that much. It means minus 900 times the cosine is equal minus 600. So now we are solving. Now I need to isolate this term. I need to isolate that term right here. Okay. So to isolate this, I'm going to divide by 900. I meant by minus 900. And then I will get the cosine by itself. It means the cosine of pi over 4t equal, now the 0 will go away, minus minus, it's a plus, so I will get 6 over 9. It means if I reduce it, this will gonna give me 2 over 3. So the cosine now is 2/3. Okay, so like we did before, the numbers are just bigger. That's what it is. So I need to isolate the cosine. I take away the 2,000. I isolate my cosine. I am right there. Now I need to solve for t. So we have to get this piece out. And the only way we can do that is using the arc cosine. It means pi over 4t is going to be cosine inverse, or the arc cosine. They mean verbatim the same. Okay. So now we're going to find t. So it means pi over 4t equal the cosine inverse, and that's really where I'm going to back up to my calculator. So the cosine inverse, sorry, of 2/3, which is going to give me 0.841. And now I need t. How can I get t? Okay, so now I got pi over 4 times t. How can I isolate my t now? Would you guys let me know? What would you do it? How would you isolate your t? There are several ways. I would like to see how would you guys do it. Multiply by 4, divide by pi. So what your classmate is saying, that's one possibility. To isolate my t, I multiply both sides by 4 over pi. I multiply both sides by 4 over pi. And the benefit of that is those 4 simplify. This will isolate my t and I will get that. So it's 0.4 times 4 over pi. And the rest is pure calculator. So I'm going to multiply by 4 over pi. And this is gonna give me the T would be 1.07. And the unit is years. Yeah. So it means after 1 year, a little bit over a year, the population will be 1,400. That's really what we are trying. How long it takes for the population to reach 1,400. So we need a little bit of work, not much, and then 1,400. We need 1.07 years. Can I move the paper, or are you guys still writing? Anybody still writing? Okay. All right, so now let me go back to the picture here. So according to my picture right there, so that's the graph of the population. This is for 1,400. So when the population, according to my picture, what are the numbers? It means right here. So right here, this is 1.07. That's really the first time. Now, my question is, use the symmetry in the graph to find all the time when the population is 1,400. Okay, so let me take you back to this picture. Between 0 and 8. And how many times will the population reach 1,400? Does it reach it once or twice? Back to you. Is the population 1,400 at 2 different times or only one time, according to the graph? Twice. So the population is 1,400 here, and it's 1,400 here. Now, how can we use a little bit the symmetry of the graph? Okay, we're gonna use the symmetry of the graph to a little bit figure out this one without doing a lot of math. Let us figure out, use the symmetry of the graph. So this is 8. This is what's happening over one cycle. So this is 8. That's my cycle. Okay. And the question is, how can I use the symmetry? Yes. Yes, 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 you did. All right. How can I use the symmetry to be able to find this point? One thing about the cosine graph is that we have a total symmetry. It means those two pieces, this piece and this piece, are mirror image of each other. So how do you think I'm going to find that? All right, one of your classmates is giving us a clue. What she's telling us is that the symmetry tells me that this is the one I found, 1.07. By symmetry, this is from here to here, the same thing. That's also 1.07. So my other answer is, so what's going to be the point here? This is going to be the 8. So this point here is going to be the 8 minus the 1.07. And that's the other time we're getting. Okay, so the second value we get just by looking at the graph and realizing, you know, there is total symmetry in this graph, and that's the one that we're going to be using. So the other value is, so now the values will be, the first one is 1.07. And the second one is going to be 8 minus 1.07. So there are 2 times when this population is reaching that. And we're figuring this out usually basically by looking at the symmetry of the graph. We use algebra to find the first one. Total symmetry will give me the second one. All right. Now we're going to do another one, and now I want you guys to participate more. So I'm going to give you more time to look through it, and we analyze it. So, sorry. I'm going to do another one. Oh, I forgot to change this. So, this is a Ferris wheel problem. And I'm giving you the height of a rider on a Ferris wheel problem is given by. So that's the height. The formula is, sorry, it's cosine. Cosine pi over 3t plus 12. Okay, and that's the formula. So on bright space, I should change that. So remember the Ferris wheel. somebody is going up on the Ferris wheel and the height changes. And that's the formula that gives you the height. Height is in meter, time in minute. After the Ferris wheel, board the Ferris wheel. Well, the graph of h of t is given to you over 2 cycles. So the person starts on the Ferris wheel at some point, go once, and then go twice. And the height, of course, is repeating itself. And I'm giving you the height over 2 cycles. Question number 1 is, find the amplitude, the midline, and the period of the function. Okay. So I'll give you a minute to figure out the amplitude, the midline, and the period. And that's really the formula given to you. Once you found them, you put them down for me and I will check them out. So what's the amplitude? So this is the formula. What's the amplitude? What's the midline? What's the amplitude? And finally, what's the period? So first I want the midline, because the midline for me is very helpful when I'm drawing graphs. Okay, the midline is y equal to 12. This is the function, that's the cosine function. This will stretch it and this will shift it. So the midline is y equal to 12. So on my graph right here, whenever I have cosine, the midline is tremendously helpful for us. This is 10 and that's a 15. So this is somewhere in between. So the midline should be somewhere here. Okay. So that's the midline. Okay. All right, that's my midline. The amplitude is the distance between the midline and the highest point. So that's the amplitude from here to here. And the amplitude is, in this problem, the value 10. And what's the period? It means how long it takes for the graph to complete a cycle. 6, absolutely correct. So the graph showed me 6. If I use the formula, the b is pi over 3. It means it's 2 pi over 3, which is equal to 6. So the period is 6. So this is my 6. This is 6 right here, right there. This is a cycle. So a full rotation around the Ferris wheel, and then it's another cycle. So this is 6 from here to here and 6 from here to here. And that's my midline. Okay. So the rider started from a top point, so probably from the top of the Ferris wheel. He came down all the way to the bottom and then back up to the top and then down and then up. So that's really the cycle we're looking at. Now, the question is, find the first time when the rider has a height of 18 meters. So at some point, the rider is going to hit 18 meters. So if this is 15, 18 should be somewhere in here. And my question is, when? That's the height, because that's the output. And the question is, I want to find is, when is the height 18? I'm going to draw the graph here. Okay. So that's the height is 18. And I want to find this piece. When is this happening? The first time. The first time the height is 18. And then we're going to find the second time, the third and the fourth. But those will be easy. I want the first time. So find the first time when the rider has a height of 18 meters. I'll give you 3 minutes to do that because I think it requires, and I will, as usual, I will pick one of you. So basically I want to find T. You want to find the time such that the height, the output is equal to 18. That's what you need to find. It means you set the height equal 18 and solve for T. Okay, that's okay. Please get going. And whoever find the answer, let me know. But I'm going to pick one of you. Anybody getting somewhere? Please, everybody feel responsible to do it because you're going to be tested on it for sure on your exam. So somebody is giving me an answer, 0.3011. Okay, I got 0.855. All right, so we're having two different answers. I want more input. Well, help. The picture showed something close to 1, but we have to make it algebraically. 0.97. Okay, Phoenix, help me out. I'm having so many different answers. I don't know which one is right. Phoenix, can you lead us?
Yes.
Get going.
Okay, so first thing I did was subtract 12 from both sides.
So subtract 12, this gives me a 6, right?
Yes.
Yeah. Okay, and then
Divide both sides by 10.
we divide both sides by 10, which is 0.6, right?
Yes.
That's an easy number. Okay, and then?
And then I took the arc cosine of 0.6.
So I put that on the right. What do you want me to put on the left?
Pi over 3 t.
Right. Is equal to that. All right.
And when I took the arc cosine of 0.6, I got I got 2.913.
Okay, I will
No,
just double check. I'm checking what you said. Everybody, please check with him. That's not.
No, I didn't get that number actually.
No.
I forgot what number I got.
Yeah. Okay. Exactly. So I'm getting and Jaden 0.927. You should get that.
Okay, yeah.
Okay.
And then subtract it by pi. Or no, not subtract it. Multiply it.
Uh-oh. If you multiply it by pi, nothing will happen.
I mean, multiply it by 3 and then divide it by pi.
Right, right. So then he's gonna multiply by 3. Because when we multiply by 3, we're getting rid of the 3 because I need to isolate my t here. Multiply by 3 and divide by pi.
Yes.
And divide by pi. Okay, so this is going to give me t equal 0.927 multiplied by 3 and divide by pi. Okay, so how we all do our math wrong? I have no idea. That's why we do it all in class. Okay, because I hope by doing this, you guys figure out what your mistake is. So what's going to be the t?
I got t equals 0.971.
Okay, I'll have to check because I'm having so many different answers and I have to check myself. No. So, okay. Okay, all of you, how much you getting here? Because I'm getting something different than from what Phoenix is telling me.
I might have calculated in radians instead of degrees.
No, everything is in radian. It's
Okay.
radian, period. The minute I start using 2 pi over b, that's radian. Anybody else, how much you guys are getting? Oh boy. Okay, 0.8855. And that's exactly what I am getting. So that's 0.927. That's the cosine inverse. I multiplied it by 3. I divided it by pi, 0.8850. And that's what the answer should be. 5, 5. Actually, let us do it at 3 decimal places. We're fine. Okay, so for all of you who did it, I hope you got your mistake. I don't know at which step you do it. So we go through the process. First, we subtract 6. So the process, the way your classmate was absolutely correct. I isolate my cosine, give me the 0.6. And then I want to get the pi over 3 out. That's the arc cosine. So I get pi over 3t is 0.927. And then I need to isolate my t. So I said, okay, I multiply this by 3 and divide by pi. And I do the same from this side. Now, in this case, those will simplify, helping me to isolate the t. Times 3 over pi, we get 0.885. Okay. Question about the process. Now I'll go back to my graph and I want to ask the following question. Okay, so on the graph, we found one value. So the value we found here is the 0.855. Okay, that's the value we found. Now, if this person go on the Ferris wheel twice, so go around and then go around, and how many times is his height going to be 18? How many times he's going to hit the height 18? So that's the graph. It's going to go down, up, down, up. How many times he's going to hit that height? Back to you. 4 times. Right here. I mean, even if you think about it, I mean, this is a circle. So he hit the same, he's going around the circle 2 times. So intuitively, he's going to hit the height 18, coming down, coming up, coming down, coming up. He's going to hit it definitely 3 times. Here, and here, and here, and here. So now we're going to find all those values, but we're going to really find them using the symmetry of the graph. So we're going to look at the symmetry and we're going to use them. So first, within one cycle, forget about the other cycle. Within one cycle, what's going to be this value here? Okay, what's going to be the value here? Okay, I'm getting answers. Let us use the symmetry of the picture. The symmetry tells me from here to here, that's 0.855. And the symmetry, what I mean, it means that if you cut it in 2, this piece and this piece are mirror image of each other, which tells me that from here to here, this is 0.855. This is 0.855. So this value here is going to be the 6 take away 0.855. So it's the whole 6, and I'm going to take away this little piece right there. So this is going to be here, 6 minus 0.855. So that's where I'm using absolutely the symmetry, which is, I think your classmate, I will copy her answers, 5.115. So that's one value. So use the graph to find. I'm going to put the values here. One value is going to be 0.855. The other one is 5.115. Now, there are 2 more times when the height is 18. Jaden, I don't know. Sorry, 885, yeah. Thanks. 0.885. Now, who can give me this value? All of you. Who can give me this value? Remember that this is periodic of period 6. It means the values repeat themselves every 6 minutes. Who can give me this value right there? So that's a period. In other words, how much do we have from here to here? How much do we have from here to here? So he reached this height after that much, and then he went back and reached it again. How long from here to here do we have? No, not 2 pi, not 2 pi, not 2, no, think a little bit more. What's the period, Rebecca? What's the period here? It's not 2 pi, the period. The period is 6. So how long for him to come back to the same point from here to here? That's really a 6. It's the period. It's not 2 pi because the period here is 6. So he's right there. Watch carefully. Go back, up, down. After 6 minutes, he's back in this position. So this value here, I'm going to call it T3. And it's going to be 885 plus 6. Plus 6, exactly. Now, this value here, what this one is going to be. This is going to be this one, and you add 6 to it. You're adding a period to that. So basically what you're doing is, again, this last value. So you start T1 and you add 6 to it. You're back where you were. You take T2 and you add 6 to it, and you are back where you were. So those are all the values that you have. Okay. So that's it for today. Please go over the worksheet we did right now, because I'm telling you ahead of time, you will definitely have problems along everything we did on your exam. Do the homework for next time, and please do the review. It's your last, is it a good chance for you to make up your grade from the first exam. Okay, class is dismissed. If any student have any questions, please let me know. And remember, I have office hours. You guys never shows up on my office hours.